All right, good morning, guys. Let's do a quick visual and audio check just to make sure you can see me. Make sure you can hear me. I can hear myself. Just want to give me a thumbs up if you can hear and see me. All right. Thank you, Karen. Good morning. Hope you guys had a good weekend. Today we just need to complete 5.4 notes. But before we do that, are there any questions on 5.3 homework? Any questions on 5.3 homework? Okay, Molly says number 3. Okay, so let's look at number 3 real quick. So number 3, the minus 4 goes down 4 from the origin, down 4, and the plus 5 goes left 5. Okay, so down 4 is the vertical translation. We're getting that down 4 from that. So down 4 and left 5. You always go the opposite of what's on the inside. So down 4, left 5 would be right here. It's taking care of both of those. Now I just have the radical x from there. Now radical x is right 1 and up 1. Right 4 and up 2. 1, 2, 3, 4 and up 2. And then right 9 and up 3. Right 9. So that would take me over here and then up 3. 1, 2, 3. And that's probably all I can get there. So it's looking something like that. And then my domain is from -5 and includes -5 to infinity. My range is from -4 to infinity. Does that make sense, Molly? Yeah, no problem. Any other questions on 5.3 homework, guys? Any other questions on 5.3 homework? All right, give me a thumbs up then if you're ready to move on and you have 5.4 notes out. Okay? Give me a thumbs up if you're ready to go on. You got 5.4 notes out and you're ready to move on. Okay, very good, Chris. Very good, Adam. Very good, Catherine. All right, well, let's get going here. All right, so we're solving radical equations, okay? And it says remember to check for extraneous solutions, okay? So it's saying solve here and check for extraneous solutions. All right. So if I'm doing that, okay, we've kind of done this a little bit already, but it's just a little bit more extended with the equation. We kind of done this a little bit with 5.1, I think. Yeah, 5.1 notes and homework. We did this a little bit. So it's the square root of 1 minus n equals the square root of 3n plus 21. So I have square roots on both sides, and I need to get those square roots off. So in order to do anything with equations, I got to do the inverse operation. And the inverse operation of square rooting is to square. So I'm going to square this side, and what I do to one side, I must do to the other. Okay? Now I do that because my goal of this is to isolate the variable, n. Okay? In order to do that, the first step would be to get the square roots off. In order to do that, I have to do the inverse of squaring, which is to square root. So the square root and the square cancel, leaving me 1 minus n is equal to, and then same thing here, the square root and the square cancel, leaving me 3n plus 21. From there, I add n to both sides, because I'm just trying to isolate n. That would give me 1 equals 4n plus 21. And then again, if my goal is to isolate this n, I need to get that 21 to the other side. So minus 21, that cancels there. And then 1 minus 21 would be negative 20 equals 4n. From there, we would divide both sides by 4. And negative 20 divided by 4 is n is equal to negative 5. Now it says to remember to check for extraneous solutions, guys. So what that means is we got to plug it back in and make sure it does work, okay? So the square root of 1 minus negative 5 is equal to 3 times negative 5 plus 21, okay? So that minus minus turns that to a plus. Minus times a minus would be the square root of 1 plus 5, which is the square root of 6. That's equal to 3 times negative 5 is negative 15. So negative 15 plus 21. And then that would take us to positive 6 as well. Giving us a thumbs up that negative 5 does work and it does equal out. So n equals negative 5 is our final answer. So what you're doing here is you're just solving for the variable and you're using those inverse properties, squaring, square rooting. You're doing all that, and then once you get your answer, you just got to plug it back into the original equation just to make sure you get the same thing on both sides, okay? And that would be what you're doing to check for extraneous solutions. Give me a thumbs up if you're kind of following me in that. Give me a thumbs up if you're following me in that. Okay, cool. All right, look at this next one. Kind of went into this one from the last one, but should be looking something like that. So 28 is equal to 7 times the square root of negative 6 minus 4n. Okay? Now, what I need to do first is because I would not want to just square this. Okay? Because then I have to square the 7 and all of this right here. Okay? So what I would want, and then square the other side. So if you have this where you have 7, a number times the square root, go ahead and divide by that number first. Divide by 7 on both sides first. The 7 and the 7 cancel there, and 28 divided by 7 is 4. And 4 is equal to the square root of -4 minus 4m. Then from here, guys, I got to get that square root off, and the only way to do that is do its inverse, which is to square it. And what I do to one side, I do to the other. Four squared is 16, so that's 16 is equal to the square root and the square cancel, leaving me -4 minus 4m. Okay, from there we add 4 to both sides. We add 4. I get 20 is equal to -4m. And then from there we just divide by -4. And we get m is equal to, again, -5. Now I need to check that for extraneous solution, so I'm going to rewrite the problem right here. 28 is equal to 7 times 4, or excuse me, -4 minus 4m. So plug in -5 there just to make sure that number works. -4 minus 4 times -5. So that would be 28 is equal to 7 times -4, and then that would be plus 20. And -4 plus 20 would be radical 16. Oh, sorry about that. -4 plus 20, so just rewrote the problem, plugged in -5. -4 times -5 is positive 20. -4 plus 20 is positive 16. And the square root of 16 is 4. 7 times 4 is 28. So 28 is equal to 28. So therefore, that is the correct answer. So kind of similar to what we did at the beginning. We did it with just a few problems with just square root on one side. Now you got to square root kind of both sides and stuff. And you'll kind of see it's not too bad. All right, so going on to number 3. 13 minus p raised to the 1/2 equals p minus 3 raised to the 1/2. Okay. Now these are both in exponential form. So what we need to do is put them in what we would call radical form. So remember, the denominator is the index. So I would say the square root of 13 minus p is equal to the square root of p minus 3. Remember, the denominator is your index. So we know there's a 2 right there. And then it's all to the first power. But since it's to the first power, we don't have to say to the first power. Then from there, what's the inverse operation of square rooting? It would just be to square both sides. So I'm going to square this side, and I'm going to square this side. Because what I do to one side, I got to do to the other. Here, this very beautifully cancels. This cancels here, leaving me 13 minus p equals p minus 3. I'm then going to just solve an equation. This is a middle school math problem. Add p to both sides. Cancels. I get 13 is equal to 2p minus 3. I then add 3 to both sides and get 16 is equal to 2p. Divide both sides by 2, and I get P to be equal to 8. We can do a quick check on this. If I put 8 in there, 8 minus 3 is 5. And then 13 minus 8 is 5 as well. So 5 to the 1/2 power is equal to 5 to the 1/2 power. So that will work. If, for say, that did not work, you would just write no solution. Okay? If you get more than one answer, that's when the extraneous is really going to come in. And you'll see here in a second we'll get more than one answer. All right? All right, moving right along. So number 4, 1 equals -6 plus v minus 4 to the 1/2 power. Now, we know we want to change that to the square root of v minus 4, and we can do that because that's taking it from exponential to radical form. But before we even do that, let's add 6 to both sides to get this away from that. So add 6, cancels. 1 plus 6 is 7, is then equal to, now watch, I'm going to rewrite this now. I'm going to rewrite it as the square root of v minus 4. Now again, we learned this last week, how you can go from exponential form to radical form. Your denominator just becomes your index, and really this is all to the first power, and that's where you put your numerator. But since it's to the first power, we know that we can just write it as the square root of v minus 4. And it's universally known that if there's nothing there, that there is a 2 there representing a square. From there, I need to get that square root off. So the inverse operation of square rooting is to square. So I square both sides. And I get 49. Because 7 squared is 7 times 7 is 49. And then the square root and the square cancel, leaving me v minus 4. I then just add 4 to both sides. Cancels. V is equal to 53. Now, if I put a 53 right here, guys, 53 minus 4 is 49. 49 to the 1/2 is the same thing as the square root of 49, so it's basically 7. And then -6 plus 7 is 1, so 1 equals 1. Again, you could take that work to the side just like we did here. I'm just kind of doing it a little mentally. Put 53 here. 53 minus 4 is 49. 49 to the 1/2 is the same thing as the square root of 49, so that's 7. And then -6 plus 7 is +1, which matches that. So that tells me that is my answer. Okay, give me a thumbs up. You're still with me? Only got two. This is going to be a quick lesson today. We only have 2 more problems. So give me a thumbs up that you're still with me. All right, let's move down here to number 5. M is equal to the square root of -40 plus 13m. M is equal to the square root of -40 plus 13m. Okay, so looking at this, there's nothing I need to move away from that square root. There's nothing I can really do within this square root. So in order to find what m is going to be, I got to get rid of that square root. Okay, I need to isolate that. I need to get rid of that square root. So in order to do that, I'm going to have to square this side in order to eliminate the square root. But I also got to do the same thing to this side and say m squared. So what I'm left with on the, let me clean this off real quick. So what I'm left with on the left side would just be m squared is equal to, and then watch this, the square root and the square cancel, giving me negative 40 plus 13m. Now, once you see that square, guys, m squared, and you see another variable, what should you be thinking? What operation should you be thinking? I can tell you this, it starts with an F. When you see something like this, this is actually called a quadratic equation. What should you be thinking about right now? Because you're not going to be able to solve that just like we did that one. You're going to have to do something else. Starts with an F. Anybody? That would be, after crickets are there, factoring. Okay? So remember, in order to solve quadratic equations that look like this, ax squared plus bx plus c, you must factor it. Okay? Now this doesn't look necessarily like ax squared plus bx plus c, but we need to move it to where it looks like that. So I'm going to need to subtract 13m from both sides. That gives me m squared minus 13m equals negative 40. And then I need to add 40 to both sides. Cancels. I got m squared minus 13m plus 40. And that's equal to 0. Then from there, guys, I solve this by factoring. So I can solve this by multiplying a times c, which is 1 times 40, which is 40. Let's see if somebody can get me numbers. What will multiply to be 40 but add to be negative 13? What multiplies to be 40 but adds to be negative 13? Someone type that in the chat box. What multiplies to be 40 but adds to be negative 13? Very good, Jake. Negative 8, negative 5. Very good, Molly. Negative 8, negative 5. Very good, guys. So then from there, since the leading coefficient is 1, that means I can do this. M minus 5, M minus 8 is equal to 0. And then I can just say M minus 5 is equal to 0, and M minus 8 is equal to 0. Add 5, I get M is equal to 5. Add 8, M is equal to 8. Now, I need to check for extraneous, because what that means is that one of these answers might not work. So I'm just going to type it in using my calculator. So I know I just have M on this side, and so negative, so I have negative 40. Dang, my bad. I have negative 40 plus 13 times 5. Now this should equal 5 here, okay? And if it does, then 5 works. And it does, okay? Same thing, but I need to try 8 now. So just plug an 8 in. When I do that, I get 8. So both those answers work. So I'm going to say my answers here are 5, 8. Goodness. Give me a thumbs up if you remember how to factor. All this making sense? Give me a thumbs up. We only got one more problem left. Let me know you're still with me. Pretty simple to me. Hopefully it's simple to you. Give me a thumbs up that you're still with me and that you're kind of understanding it. Cool, Karen. Cool, Kenny. Cool, Adam. Cool, Chris. Very good. Very good, guys. All right. So let's move right along. Good job, Jake. Good, Maria. All right, so let's move to 6. Now, 6 looks a little bit different, okay? But, guys, here's what I'm going to tell you. You always want to get the square root by itself. I'm going to write that down here. Always get the square root by itself. Okay? We know we have to square both sides in order to get the square root off. But if you squared this and then squared this side, that means you would have to FOIL all that, and that would get very nasty. Okay? So you always want to get the square root by itself. Notice up here, notice it right here, we added 6 and got the square root by itself. Up here, the square roots were by itself. At number 2, we divided and then got the square root by itself, okay? So we always want to get the square root by itself. So in saying that, I want to subtract 4 right here from both sides. Subtract 4, that cancels. I got m minus 4 is equal to the square root of 2m minus 5. Now, in order to isolate this over here, I'm going to have to, in order to get rid of that square root, I'm going to have to square this side. But what I do to one side, I must do to the other in order to keep it balanced. All right. Now, as you see here, this is a binomial times a binomial. That is FOIL, but trust me, it would be much easier to FOIL this than it would be to FOIL all that. All right? So this looks like this. M minus 4 times m minus 4 is equal to the square root and square cancel, giving me 2m minus 5. So let's FOIL this. Let's go first. First, m times m is m squared. Go outside, which would be negative 4m. Go inside, negative 4 times m would be negative 4m. And go last. Negative 4 times negative 4 is positive 16. Is equal to 2m minus 5. Now, once we combine these like terms right here, we get m squared minus 8m plus 16 is equal to 2m minus 5. Goodness, man. Long weekend for me. So then from there, guys, I just need to get these two over here. So I'm going to subtract 2m from both sides, while at the same time adding 5 to both sides. So just making that side 0, so all that cancels. And then I got m squared minus 10m, and then plus 21 equals 0. From there, I notice this is a quadratic equation, okay? Anytime you see m squared and another m, that's going to be quadratic, and you're going to have to factor it, okay? That's what triggered me to move these over here with that, because I knew it was quadratic. So what will multiply to be 21, but add to be negative 10? What multiplies to be 21, but adds to be negative 10? Someone type that in the chat box. Good, Molly. -3 and 7. Good, Adam. -3 and 7. And then since the leading coefficient is 1 here, I don't have to factor by grouping. Good, Jake. I can just simply type them in. M minus 3, M minus 7 is equal to 0. So M minus 3 equals 0 would be M equals 3 when I add them to both sides. And M minus 7 equals 0 when I add 7 to both sides would be M equals 7. Now, I need to check for extraneous solution, so I'm going to come back up here and I'm going to type. I know my answer is just an M on this side, so I'm going to type that right side out. 4 plus radical 2M. Let's go with 3 first. 2 times 3 minus 5. Now, notice here that for the M, we think one of the M's could be 3, so we put a 3 into that M. Now, because there's only one M on this side and one M right here, this answer should be 3 if 3 works. Notice that it's 5, okay? So it should be 3 equals 4 plus radical 2 times 3 minus 5. So now let's think about what this in here is doing. 2 times 3 is 6. 6 minus 5 is 1. The square root of 1 is 1. 4 plus 1 is 5. But remember, we put a 3 in there. So 3 does not equal 5. So this right here would be extraneous. So it's not a part of the answer. It's just extraneous, meaning it works out to be a solution, but it does not work once you plug it back in. That's what an extraneous solution is. Now let's try 7. So same equation. Now same thing here. Once I type in a 7 here, this should come out to be 7. And it is, so 7 is my answer. I do not include M equals 3 as part of my answer. It's just extraneous. So if a question ever asks you what's the extraneous solution of this, then you would want 3. But if it just says solve the equations, it's just 7. Even if it says remember to check for this. So we know it's extraneous, but the answer is 7 because 3 does not work. So just going in a little bit deeper with radical equations, okay? Equations with radicals in them. Just taking a little bit step further than what we did on, I think, 5.1 notes. So, and then from there, you just simply have your homework, guys. You just have your homework. Nothing on the back side. You got 6 problems for homework. Make sure you're following your steps first. And then guiding yourself kind of through there, all right? Shouldn't be, homework doesn't look too bad at all. Just remember to go from exponential form to radical form on 5 and 6, and the rest should be pretty simple. Make sure you divide by 4 there first, okay? Any questions of me? Any questions of me over 5.4? Notes or homework? All right, give me a thumbs up if you're good for 5-point homework. Give me a thumbs up. Is there a 7 or 8 on there? Oh, yeah, I'm sorry. Yes, I didn't see that, Karen. Thank you. On the back of that, yeah, do 7 and 8. I'm sorry. But don't do 9 and 10. I marked those out. Thank you, Karen. So you got 1 through 8 for homework. Making sure everyone hears that and sees that. 1 through 8, there's 2 on the back side. Please do those. Those will be good practice. So 1 through 8, 7 and 8 are on the back side. Okay? Make sure you do 1 through 8. I said 1 through 6. I will now retract that. That didn't happen. And make sure you do 1 through 8, 7 and 8's on the back side. If you guys don't have any other questions for me, hey, this is a pretty short lesson today. So thumbs up. Sometimes we have long ones. Sometimes we have shorter ones. This was a shorter one. We had a little bit of prior knowledge to this. So pretty simple within itself. So if you have any questions, email me. If not, I will see you guys back here Wednesday at 12:45. Thanks so much, guys. Have a good day. I'll be on here for a few minutes if you have any questions. Thank you.